Welcome once again to a quiz show which aims to provide a behind-the-scenes look at how things actually work. Yes, that's right. Quest, a joint production between the National Council of Science Museums and the Doordarshan Kendra Kolkata, aims to do just that. Through a series of very interesting examples and experiments conducted today by the director of Nehru Science Centre, Mumbai, Mr. G.S. Rautela. Welcome, sir. Oh. Mr. Rautela, I've asked you this question many times before. Are you enjoying Calcutta?
Yes, very much.
And I believe you are a man in a hurry today.
Oh yes, I have to go back.
A flight to catch to Mumbai, all right. Well, let's not waste any further time in that case. Let's introduce the teams to you. On my right is the 𝐺𝐶 team, and you are?
I'm Anvishrat from 𝐾𝐕-𝐨𝐬𝐭𝐫 1.
I'm Shashwata Chakraborty from 𝐾𝐕-𝐨𝐬𝐭𝐫. I'm studying in class 12, Science.
Rubal Shah, class 12, Science.
I'm sorry, I didn't get that name right. You are?
Rubal Shah.
Ruble, like the Russian currency?
Yeah, exactly.
Now tell me, why did your parents name you Ruble?
You have to ask my parents.
I have to ask you. Did you ever ask them that question?
No.
Did not ask that question, all right. We'll be asking a lot of interesting questions today, Ruble.
Okay.
We hope you have the right answers. And on my left is the C.V. Raman team. They are the girls from Mahadevi Birla Girls Higher Secondary School. Did I get that right? Yeah. I did, yes. And you are?
Rashi Agarwal, class 12, Science. Hi, I'm Nitisha from MBJ, class 12.
I'm Sriushi from class 12, Science.
Let's give both teams a big round of welcome. Rules of the contest, very much the same as before, 7 questions in all, 4 of them are direct, 20 points for the direct answers, 10 on passes, 15 seconds to answer. In the buzzer round, plus 20 and minus 10. More about that when we come to that. First question in today's show is for the 𝐺𝐶 team.
I have a bottle, I pour little water into this, and I have 2 holes in this bottle and 2 water just come out. Now I'm performing an experiment. When I drop this bottle, when the jets are out, tell me why these jets disappear. Once again, why do they disappear?
It is because of the potential energy. When the bottle is at the higher level, the potential energy, the height is more, so the potential energy is more. As a result, the jets are coming more.
Energy level.
But when it is getting, when it is coming to a lower height, then the potential energy decreases. As a result,
they stop instantaneously. Could you like to try? No, that's correct answer. Would you like to try?
Girls don't have an answer? Not trying? Anyone in the audience? No one in the audience, Mr.
Oh,
Rautela.
it was as simple as one could expect. When I'm dropping, the water jet loses weight, it's free fall.
Oh, shit.
Okay, value of G becomes 0, the pressure becomes 0 on the water, so that's why the jet stopped coming out. As simple as that.
Well,
somebody gets a point.
both teams failing to get off the mark there. Same 2 for the audience. No takers in the audience there. Next question is for the C.V. Raman team.
Well, your question is, I have a container which has some plastic granules, and I have a ball which is quite heavy. I put it on the top of this and shake the container. The green one comes up. Now the question is, why does that heavy ball go down and the light ball comes up?
Under the effect of the force that you are applying, the heavy ball being heavier, it goes down under the effect of the force as well as under its own weight. And as a result of a reaction of that force, the other lighter ball comes up.
Could you tell me what is the force acting on the lighter and heavier?
The force acting on the heavier one is gravity. Yes, force of gravity plus the force which you are applying to it.
When I drop a lighter and heavy ball together, do you think the heavier will fall first?
In a vacuum, it won't.
Otherwise?
Otherwise, yes,
size?
because air resistance is there.
If they are same size?
They are same size, no. They fall at the same rate.
Tell me, what is the force acting then here?
The force acting is mg.
Well, it's not only mg, what else happens? Would you like to try? That's not quite a correct answer. Would you like to try?
Centripetal force.
Centripetal force or centrifugal?
Fugal.
Yeah. Then what happens with the?
There is a tendency to skid down,
Yeah.
so it goes to the bottom,
Yeah.
and due to skidding, the lighter ball comes up.
Yeah. When you winnow, you must have seen in villages. The villagers do when they winnow, the stone particles settle down, the light particles cover. Okay. That's exactly what is happening here. So you get 10 bonus points for this. So when I am rotating this, the heavy ball being heavier, of course, and when it is thrown away faster, so it tries to go away and the lighter ball comes up, because the force at the center is minimum, all right, because R is 0 almost. So that's, you get 10 bonus points for this. What was correct answer?
Well, Rubel, it was heartening to see that you knew more about how this ball came up than you knew about your own name. Anyway, well done. 𝐺𝐶 team, you pick up 10 points. That's 10 bonus points. And the next direct question will be for you.
Well, your question is, I have some soap solution in this petri dish. I have a funnel, and when I lift it up, the soap film tries to go up in the funnel. Okay. Once again, see this film tries to go up and become smaller and smaller. The question is, what makes the film go up?
The tendency of a soap bubble is to attain the minimum surface area, and as the soap bubble rises upwards, we can clearly see that it attains minimum surface area.
Why?
Because the tendency of a liquid is to attain minimum surface area.
What is that? Why it tries to do that?
Because of surface tension.
Yes, that's what I'm looking for. We got 20 points. Well, a small add on this. If I close the funnel from the top, will the film rise up? If I close the funnel from the top, will the film still become smaller?
No.
Why?
Because we don't get the air passage out, perhaps.
You are to some extent right. The surface tension is much smaller than the air pressure. So that's why the film cannot rise. You can see this. If I close it from the top,
Yes,
see now the film doesn't rise. If I remove my finger, it rises up again.
Yeah.
All right? Okay.
Good answer there, Shashwata. You pick up 20 points for your team. Your team moves on to 30 points. That 𝐺𝐶 on 30. C.V. Raman, next question is for you. The score's reading 30 love. That's right. 𝐺𝐶 team, 30 points. C.V. Raman yet to score. Come on, girls. Let's see what you do with your direct question.
Well, I have two solutions here. One is potassium permanganate, another potassium permanganate with a little KOH. It's aqueous potassium permanganate. If I add hydrochloric acid to both of that, see what happens. In this case, it has become almost colorless, and in this case, it is turning yellowish green. Now tell me what really is going on.
happening.
5 seconds.
In the first case, by the reaction of hydrochloric acid and potassium permanganate, we obtain KCl along with hydrogen permanganate.
No, that's not quite correct. Would you like to try?
In the first case, when potassium permanganate is treated with hydrochloric acid, then we get KCl, MnO2 and H2.
No, I think that's not quite correct. Would you like to try, anybody in the audience?
No one in the audience? Yes, you would like to try?
Yes.
You would. Why don't you come up? Come. Come up. Hold the mic. Come behind here. What's your name?
Hi, I'm Devanshu Mishra. I'm from Kendriya Vidyalaya number 1, Labuni, Salt Lake.
Yeah.
So I think this is due to the change in pH value.
pH anyway, when you change, add acid, pH is changing.
Yeah, so
Something
that's what its reason is.
No.
No,
I think I would give you the answer for this. In first case, potassium permanganate is reduced by chloride ions of HCl into manganese, Mn, because concentrated chloric acid. In second case, in the aqueous solution, it is manganate ions, it is converted into manganate ions, and that's the reason it's greenish in color. So it's, in one case, it is totally reduced into manganese ions, in another case, it is not reduced, it's MnO2 ion, which is greenish in color. All right?
Scores exactly where they were. 30 to JC Bose, CV Raman yet to score. Next question will be on the buzzer. Scores, as I mentioned before, 30 to the JC Bose team, CV Raman yet to score. Next questions on the buzzer. Remember teams, plus 20 if you get it right, minus 10 if you get it wrong. These questions will not pass to your counterpart teams, they'll go straight into the audience. Mr. Rotella.
Well, I have this propeller toy, you all know it. When I rotate this, why does it go up?
Yes?
Now the question, who's going to answer?
Because of the Bernoulli theorem, you are applying some force, and force is inversely proportional.
So when the velocity is increasing, the pressure is decreasing.
Where?
When the velocity of the fan is increasing, the pressure on that of that region is decreasing.
Yeah.
So
At
the
the bottom the pressure is decreasing.
At the bottom?
Yeah. So at the bottom the pressure is increasing. As a result, it is and the top the pressure is decreasing.
Decreasing.
As a result,
the
increase
tendency of the fin will
pressure
be to-
difference,
Yeah.
the plane is arising.
Now question is, why does it not decrease at the bottom? Why does it go up?
Because say the velocity of the fin is increasing, so the pressure must
No,
decrease.
but why not at the bottom?
Because the air is as we are rotating that pipe-like thing.
Your
We are getting
explanation
some
all right,
force
but
here.
you have to tell me what has to do with the rise, what makes the low pressure at the top.
Actually, you are giving
If
pressure.
I had a flat blade, would it have done it, the same thing?
We can take the example of a aerofoil.
Yes.
Yeah.
Okay.
In the
That is also in the upper portion of the aerofoil, the pressure decreases because the streamlines are increasing. They are not crowded.
Anything aerofoil has to do with this toy?
Maybe that theory.
I think you gave partially correct answer, but the shape of the blade is very important here, because it's a tangential rotation on the top. That's why low pressure on the top, the speed is higher. As a result, it goes up. If you look from the side, the blades are exactly like aerofoils.
So I
Yeah.
gave the
So
example.
we give you a point, but anyway, you have to tell the shape is important. You get 20 points for this.
Mr. Rotella, is this not how a helicopter
Yes,
rises in the air?
exactly. Exactly. This is the principle applied in all the rotors, where you need lift or a drag, whatever you like, with the rotors. Designing the rotor in that way, you can get a lift or a drag.
It's the fins which are angled and then displacing the air
Yes,
which
right.
is below.
That's
I
correct.
think that was the answer which was more relevant here, Rubal. Anyway, you pick up 20 points for your team. Your team now moves on to 50 points. Girls, come on, you can do better than that. Got 2 more questions to go. Let's see what you do with those. Sixth question in today's quiz. Scores reading 50 to the JC Bose team. Girls from CV Raman team yet to score. On the buzzer, here we go.
Your question is, I have 4 rings pasted on this box, and they have different diameter. When I give a vibration of various nature to this, it's very slow, you find the big disc, big ring makes a vibration. A little more, you find the smaller one vibrates. You can see this way, and if I increase my speed, you will find the bottom, the smallest, the last but one ring oscillates. The question is, why does it happen? Why not all of them oscillate?
Ten seconds. I'm afraid neither team going for that. We have to go into the audience. Anyone in the audience with an answer? Nobody, Mr. Lotela.
Okay, and I have to
Once
answer.
again, yes, sir.
Well, these rings are different diameters. So as a result of this, their natural frequency is different. So when I am vibrating it at various frequency, the frequency matching to that ring's natural frequency will make it resonate. Okay, and it will oscillate much more than the other rings. Okay, that's the simple answer.
No change in scores there. Still on 50 to the J.C. Bose team. C.V. Raman yet to score. Welcome back. You're watching Quest, the weekly inter-school science quiz brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. We are in the final lap, the last question. Girls, this is your final chance to do something. Are you going to score now?
I'll try.
You'll try. Okay, let's see what you do with the next question. Here we go.
Well, I'm going to blow a balloon now here. Now, if I hold the balloon like this and open the mouth towards the boy's side, now my question to you is, where will the balloon go? Towards you or towards them or somewhere else?
Okay, the girls have finally gone for the buzzer.
Let's see what really happens, if you are right
The
or wrong.
balloon is going to move towards us because when we release the balloon.
No, I'm not asking the answer right now. Let's see what really happens. It doesn't go. Now, your question to you is, why it doesn't go in the direction you predicted?
Come on, girls, 5 seconds to go. Not trying, I guess we have to go into the audience. Any takers in the audience? No one in the audience? Well, J.C. Bose team, would you like to try and answer? No points to you.
At least I can try.
Yes, Rubal?
When we are blowing the balloon, we are giving much more pressure, which pressure is less than the atmospheric pressure outside. So when we are just releasing the balloon, it's going nowhere.
I'm afraid that's not the right
That's not the correct answer. Well, it's a very simple one. As they predicted rightly, according to Newton's third law, which is the principle of rockets, if you allow air to go in this direction, the balloon should have gone towards them. That's the normal prediction everybody makes. But in this case, that would happen only when the balloon is very uniformly made, perfectly spherical, and it is equal mass distribution in all directions. It would happen. But these balloons are never having that kind of distribution of mass. They are very irregular, different density, and when the air comes out, the contraction also doesn't take place uniformly. Okay, so they expand ununiformly and also contract ununiformly. As a result, it doesn't go in the direction it should have, as you predicted. So that's the simple answer for this question.
No score to either team. Scores remain exactly where they were. That's 50 points to the J.C. Bose team. C.V. Raman team did not score. And since we cannot take anything away from what they did not score, you still remain on no score. With that, we come to the end of today's quiz. J.C. Bose team, handsome lead. They've got a total of 50 points. Thank you for coming on our show. Let's give a big round of applause to them. We have a small memento for you to take back to your school. Anvesh, Shashwata,
Thank you, sir.
and Rubal. Girls, Sorry you could not score anything, but thanks for coming on our show. Rashi, Nikisha and Shreyashi. Thank you very much. Do write in with your comments. Our address is Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll be back again next week with another new set of experiments, 2 new schools. Till then, it's goodbye to you from the production team here at Doordarshan Kendra, Kolkata.